Hi everyone, today I will present you our work ExoForm, shape memory, and self-fusing semi-rigid wearables. Semi-rigid and rigid wearables like splints, casts, and braces have been used in many on-body applications including musculoskeletal support. Customized fitting is challenging for current devices. They are heavy and take a lot of space to transport. The majority of those devices were designed and handcrafted by medical professionals, so the quality and design are directly related to doctors' skill and experience. We want to find some off-the-shelf solution for users. Here we introduce ExoForm, a compact, customizable semi-rigid wearable material system with self-fusing edges. ExoForm can self-fold triggered by heat, like shown in the video on the right, and flattening itself whenever needed. We also integrate temperature sensing and control into the system. Our technique augments semi-rigid wearables for adjustable and reusable cases, so users can use it without dependence on medical professions. Let me talk about the multi-step wearing procedure for ExoForm. On the left, we show a video of user holding the piece to do an off-body self-folding for ExoForm. On the right, shows how user can wear the piece and massage it to fit their neck. We propose the following layer composite for ExoForm. Different layers are bonded by 3M BHB tape. From the literature, it is shown that it's difficult to control the transformation of PLA actuators longer than 10 cm, so we adopt a novel PET constraint layer to improve bending performance. Next, I want to demonstrate how self-fusing edges can connect multiple pieces. According to our test, after 2 minutes of healing, we can move the body without breaking the self-fusing edges. Also, the self-fusing edge can be broken down and rejoined repetitively for reuse. This video shows how we can use resistive heating to morph a wrist support design. To select a heater material, we consider conductivity, flexibility, and ease to fabricate the material. We evaluate power consumption of each material and show in the table. We conclude that we will use copper foil for large surface and silver printed directly on PT film for smaller design. The image at the bottom shows the heater designed and fabricated on the sample. The most right image is the IR heat map for next sample. This video shows the how temperature sensing works. A white LED will light up and red LED turns off when the temperature falls below 60 Celsius degree. This video shows how we can sense the tightness of fitting. The closer the ExoForm is to skin, the dimmer the light becomes. In the pipeline of ExoForm, morphing behavior is visualized through an abacus FEA simulation. For example, in this figure, the fitting feedback of the initial design does not fit in the neck very well. After designer getting this feedback, they can update the design and integrate bending behavior into the vertical beams to achieve better fitting result. This video shows the fabrication pipeline for ExoForm. We use two kinds of self-fusing material in our applications. One is 1% multi-wall carbon nanotube PBS, fabricated by ourselves, and the other one is the off-the-shelf material, thinking putty. For multi-wall carbon nanotube, we first spread it and then make a thin film, and then cure it in oven for 12 hours. This procedure gives better adhesion of material and ExoForm. For thinking putty, it can be directly applied to the PLA with printed mesh. We want to emphasize a few design features for ExoForm. The first one is semi-autonomous two-step assemble. Every application is fabricated at the flat piece and then can be applied through two-step procedure, off-body loose fit and on-body tight fit. The second one is self-fusing edges. We use multi-wall carbon nanotube PBS in our finger support application and thinking putty for the rest of the applications. The third one is reversible actuation. By using PET and PLA structure as a shape memory actuator, we can achieve reversible actuation for relatively large samples. The last design feature is flat packing. Comparing to the volume of the 3D shapes for all applications, ExoForm saves a lot of space by fabricating as flat pieces. ExoForm is a novel approach to the fabrication and design of semi-rigid wearables that incorporates all the design features I just mentioned. Ultimately, the ExoForm process produces solutions that work across body types in any environment. This level of accessibility means that future devices can be tailored to fit users' needs without leaving anyone behind. That's all. Thank you for listening.